Hello everyone. In this video, we are going to learn how to determine the rigidity modulus of the material of a wire and moment of inertia of annular ring. When we are applying the external force on the body, then this external force can be quantified in terms of stress, that is force per unit area. And the deformation of the body can be quantified in terms of strain, that is the relative change in the configuration of the system. Now, within certain limit, the stress is directly proportional to the strain, and this is known as the Hooke's law. So this proportionality can be replaced by a constant K, and this proportionality constant, it is known by many other names depending on the type of stress and strain. For example, this K is known as the Young's modulus when we are talking about compression or expansion, or you can say linear compression or linear expansion. It is known as the bulk modulus when we are talking in terms of volume strain. It is known as the shear modulus when we are talking about the shear stress and shear strain. Now, if we consider an elastic body and we apply an external force, then a restoring force will be generated inside the body. And this restoring force will try to regain its initial configuration of the body. And during this process, the body will oscillate. The oscillation depends on the inertia, that is the mass, damping, that is the loss or the friction in the system, the external force, and also on the elastic property. Some of the examples are the spring mass system, where the mass oscillates around its mean position. We have the simple pendulum. We have the torsion pendulum. And we have the bending vibration of cantilever beam. Now, finally, let us talk about inertia and moment of inertia. What is moment of inertia? Is it the same as inertia that we talk in linear motion, or is it different? For that, let us consider a body which is at rest. Now, we apply a force so that the body comes in motion. In the second example, suppose the body was already in motion. Then we apply force in opposite direction and the body can be brought to rest. In both the example, the state of motion is changed. And inertia is defined as the tendency of a body to register change of state of motion. For example, in the first case, it is changing from rest to motion. In the second case, it is changing from motion to rest. Now, the tendency of this body to resist this change is what we call as the inertia. And this is quantified in terms of mass. Now, we take another body, and this body is rotating about an axis. Now, how do we define inertia here? Is inertia directly proportional to mass, or is it something else? In this case, that is in rotational motion, the inertia depends on the mass and also it depends on the distribution of mass around the axis. These two factors, it is combined and it is quantified in terms of moment of inertia. The aim of this experiment is to determine the rigidity modulus of the material of a wire and moment of inertia of annular ring. The apparatus required are annular ring, stop clock, screw gauge, torsion pendulum setup, and vernier caliper. The first part of this experiment is measurement of the time period without the ring. The video on the left hand side will show you how to do it. Apply a marker on the disc using a chalk. Then you give a small angular displacement. Leave the first few cycles. Once it attains a stable oscillation, calculate the time period for 10 oscillations. The next part is the measurement of the time period with ring. The video on the right hand side will show you how to do this. Insert the annular ring on the disc. Give a small and angular displacement. Lead the first few oscillations. Once it attains stable oscillation, using the stop clock, you measure the time period for 10 oscillations. After measuring the time periods, now we will measure the different parameters of the wire and the annular ring. On the left hand side, here we are showing a video how to measure the length of the wire. From this point till this point, we have to measure its length. So we'll be using a meter scale and place the meter scale vertically and measure the length. Then, using a vernier caliper, we will measure the inner and outer radius of the ring. Then, using a screw gauge, we will measure the thickness of a wire. While measuring the thickness, we will take 3 different observations at the top, middle, and the bottom part of the wire. This is observation table for measuring the thickness of a wire. This is the observation table for measuring the time periods. For the case of without ring, the mean time period is represented by TD. And for the case of with ring, it is represented by TRD. The rigidity modulus of wire will be calculated by using this formula. The moment of inertia of annular ring will be calculated by using this formula. The theoretical result of the moment of inertia of annular ring will be calculated by using this formula. There are some of the precautions. The time period of the oscillation should be measured after the pendulum starts stable oscillation. The meter scale should be kept vertical while measuring the length of the wire. The thickness of the wire should be measured at 3 different positions and we should take the average. If zero error is present in the screw gauge and vernier caliper, then proper corrections should be done in the calculation.